in your book, the opening chapter is called "Are You Normal?" Hint: No. So how do you feel about this common misunderstanding of "quote unquote" being normal, especially in a society that values conformity? Maybe not as much as China, but yeah. So there's a question for you.
Right. Well, I think there are two chapters that are really on this theme. And as you said, one of them is about normality and the other is about extremes. The chapter about normality was one of the ones that surprised me, and probably the most enjoyable part of reading this book was when ideas would bubble up and surprise me. But this one comes from looking at measurements of human beings. It's a data set that was actually collected by the Army. They have 93 different measurements of every part of your body. Um, and I looked at one measurement at a time, and it behaves exactly as you would expect. Almost everything is well approximated by a Gaussian distribution, which has this property, which is that most people are in the middle and close to average, and a small number of people are at the extremes. And
Mhm.
I think we have a strong intuition for what it means to be normal that is based on that Gaussian
Yeah, yeah.
curve. That if
And that, but just for our listeners who aren't aware of the guessing, it's the bell curve. So it's this common curve that you see in, it's, you talk about college grades or whatever being fit to a curve, that bell curve. It's the Gaussian curve. Anyway, sorry, I interrupted you.
Yeah, no, that's a perfect example. In fact, I started with height, and height is one where, most people are close to average. And
Mhm.
so we think of that as being like a normal height. And when we design things like cars and doorways and anything that depends on the proportions of a human body, we tend to focus on people who are close to average. And if you are very far from average, that's both rare and weird. And I'm going to put quotation marks on weird, and we'll see why in a minute. That if you are extremely tall or extremely short, that's not, again, putting quotation marks on normal. But it turns out that our intuition, when we look at one measurement at a time, is totally wrong when we look at many, many measurements.
Right.
And this comes partly from research that was done by the Air Force in the 1950s. They were designing cockpits for airplanes. And you need to fit in a cockpit in order to operate the plane as well as possible. And so they took 10 measurements, and they wanted to find pilots who were close to average on all 10 of these measurements.
Mm.
So if someone was too tall or too short, they would exclude them, and they would take the middle people and say, okay, well, now if your hips are too wide or too narrow, you'd be excluded. And
Mhm.
at every step, every one of these 10 measurements, you would lose a few more people because they were too weird for a
Mhm.
standard cockpit.
Mhm.
And you probably see where the punchline is, which is
Yeah, yeah, yeah.
nobody makes it through all 10
Right, right,
measurements.
right. Yeah.
Everybody is weird in some way. And in fact, when you have 93 measurements, it's even more extreme. And it turns out not only is everybody weird, but everybody is about the same amount of weird. And
Oh,
and
whoa.
I did that by looking at, like, I would give you a point. For 93 measurements, you would get a point for every measurement where you are weird. And then I looked at what is the distribution of points. And out of 93, if I remember right, the most normal person was weird in 40 ways. And a typically weird person is like 60 out of 90. And the distribution is not very wide. Like, the difference, if you are weird in 40 ways or you are weird in 60 ways, it doesn't really matter. That is, in my way of thinking, about the same amount of weird. And by the time you get up into thousands of different ways that people vary, what you find is everybody's about the same amount of weird.
That's super fascinating. This is it's I guess it's something that I kind of intuitively thought about before, but I've never had these kinds of hard numbers around it. That 40 to 60 range is very far away from what I would have thought it would be. I would have thought it maybe like 10 to 30 or something. And so then what's your like weird threshold? Was that like a standard deviation away from the mean?
For that one, yes, it depends very much on where you put the threshold, and it's kind of arbitrary. So I don't want to overstate the result, but there's a mathematical view of this, which is in a multivariate distribution, most of the probability density is in a thin shell that is a distance away from the origin. And so that's a mathematical way of saying that the density that's right at the origin, like average in every possible way, is approaching zero. And if you go and search in this multidimensional space to find the people, you will find them all at roughly the same distance from the center.